Ladies and gentlemen, welcome to RPI Data Science. Until now, we have seen how you can read text data, how you can do bibliometric analysis, how you do text mining, like going through the details of the text data and finding out the most common terms. And we have plotted them in word clouds, network graphs, and also we have seen a visualization of bigrams and unigrams using multiple different plots. Last time we have talked about how to calculate TF-IDF values and the intuition behind TF-IDF, how you calculate it using the tidy text package, and we have seen the ways of visualizing the most common, like the most influential terms, because the influence or the importance of the word, the relative importance of the words or bigrams or unigrams, it's mainly calculated using TF-IDF values. So the terms that have bigger TF-IDF value will be considered as influential terms. But otherwise, the other terms, the terms that are really rare, or the terms that are very common in your text data, will have the very small TF-IDF value, which will be less important in your text data. So today I would like to continue from the previous session, which will be about reading conducting text analysis using a different package, Quanteda. So as I previously mentioned, there are numerous packages which you can do text analysis in R. The first one that we have demonstrated in the last session is tidy text, which is really nice package. It also has a nice tutorial, freely available online resource, which you can. There is also a hard copy book. I personally have it. I really like it. So tidy text is one of the packages that you definitely would enjoy. And the other one is TM package. That's also a really nice package, which you can try. I haven't used it very much, but I also liked it. The other one is RText tools. This is really something which has been written before 2012, so it's really old package, and no one is maintaining it, and no one is. So I don't really recommend using this package, because if you start using it and if you are running into problems, there will not be someone who will help you. I don't actually think there are people who actually use this package. So I definitely don't I don't recommend using this package. And the other one is text2vec. Text2vec is really a nice package if you are actually if you would like to work in topic modeling, also in text vectorization or something. It's also super fast. This computationally very efficient package. I heard the author of the package is very obsessed in computational efficiency in terms of time required to complete a certain text mining task. So this could be something that you could try in case if you have large text data or something, and if you are interested in doing some unsupervised learning. Instead of, even for text classification, you can also use it. Especially you can combine it with explainable machine learning tool, Lime package. So you can use in combination with Lime, and then you can use that's a very effective combination. So I have used it, but not very much into but just I used it for blog post or something, but I haven't implemented it for my own research. But the main package that I have worked through is Quanteda. I like Quanteda package because it's easy. It has an easy to read tutorial page. They have a nice page, and also it also has many super useful functions which are also very fast. And the other one why I recommend this package is because the people behind this package, the authors, they are super helpful. If you are running into problems, you can post a question in Stack Overflow or GitHub. They will definitely jump in to help you within 10 or 20 minutes. I was really surprised with how they are supportive. And they also have a nice tutorial which I can show you. This is a tutorial page. It's really, now it's on 3.20, so that's the current version of the package. I have also recently updated my own, so you can simply install it, and they have really a quick tutorial guide and all the functions. They are really, and they also have actually in other languages, you know, in Chinese and in Korean. I think this is Chinese, and this is yeah, this is I don't know. Okay, anyway, it has a nice tutorial page, and I really like the package, and yeah, so I have enjoyed it. And the other one is actually, it also has some other additional package which is called Quanteda text models. It has some machine learning models like support vector machine, mainly linear support vector machine, and also they have naive Bayes algorithm. The other algorithms, I think they have also recently added additional algorithms like you know, the regularized logistic regression models for classification. Like lasso, elastic net, and ridge regression. I think they have included that in this package. But I think for regularized, I really like it for support vector machines because it's fast, it's linear support vector machine. But we will come to that later on, and which we will see whether using support vector machines from E1071 or support vector E1071 is another thing, another package for doing support vector machines. So whether you need to use Quanteda text models for running support vector machine or E1071, at least it's a very popular package, E1071. Yeah, you decide. I mean, for Quanteda, it only helps you to run SVM, linear SVM. Doesn't have additional kernel choices for other SVM kernel types. But yeah, for something quick, you can use it. It's very quick. It can finish the model within few seconds. But if you use E1071 SVM, and if you do hyperparameter tuning, and depending on your text data, it may take long time. I think that's the main advantage of Quanteda text package, Quanteda text models package over E1071 SVM. So having said this, I would like to continue to our today's session. So what I want to do today is I would like to continue with text analysis using Quanteda. So our today's agenda will be, we will, as we did last time, we will read the data. The data we have is about half of the data is about COVID, and the other one is about SARS. So these two data were searched COVID in 2020. So the COVID literature in PubMed. I was simply searching it in PubMed. So you can simply go to PubMed and search COVID 2020. So something like this. So let me bring PubMed here. So you simply search COVID. So I'm just typing COVID, and you have I applied some year filter, and I was only yeah, the output will be only publications that were published in 2020, and everything is about COVID. So once I have done that, I exported all these references after selecting, actually not all of them, 600 of them. And then once I exported COVID, I also tried to export SARS, but it was on 2003, because you know SARS pandemic was in the 2003. So that means I will only have two types of data. One is about SARS, and the other one is about COVID. My whole aim at the end is to classify based on my machine learning model, is to classify an abstract by machine learning to predict whether this abstract is about COVID or about SARS. That's why what we will go. What we will do in our machine learning session. But to achieve that, once we read the data, we will split the data into training set, and test set. and this is because we want to train a machine learning. So if you want to train a machine learning model, you need to train it so that the algorithm can learn from the data, can learn the relationship and calculate the parameters, I mean the mathematical relationships. And then once the algorithm learns about the data, then you will give it the test set, and the test set it will predict the outcome. So it will be based on the relationships that it has learned from the training set, it will be able to give you the output for the test set. I mean, it will predict. When you split the data using split the data into train and test set, so what you have to do is, usually it's recommended to do majority of the data set to be assigned for training set, and because you can assume machine learning models, machine learning algorithms as like babies, just jump into the world. So let's say if one baby is just born and live in let's say in the US, so maybe in the US not really, because US is a very diversified country, but if you see there is one let's say one country who doesn't have any diversity, like there are not many faces, there are not many different human faces, then the algorithm will only identify that particular person. It doesn't know any other human being, any other human type. So there will be, so you need to expose this baby to many different data types, many different at least type of people. Then the baby will learn all the human races. And usually it's recommended to assign a majority of data set for the training set. So that's like, it could be 90% or 80%. Maybe I often do 70%, but you can, that depends on how large is your data, how large is your observation. Let's say if you have a million observations, then if you assign 70 or 80%, the number of observations in the test set will still be high. But if you are dealing with the data that has only 1,000 records or maybe 2,000 records or something, then I would go for 80% in the training set, or 20% for the test set, or 70% in the training set and 30% in the test set. So I often do 70-30, but I also tried 70-30 and 90-10. So the performance, of course, improves. The larger the data you give for the training set, then the prediction will be much more accurate if the model is trained by larger data set. So once we split that data, we will tokenize. We will tokenize as we saw in the past. We'll do the same tokenization procedure, just using this time we will only use Quanteda package. Quanteda is actually quantitative text data or something. I don't know. You can look at the abbreviation from the package. So we will tokenize train and test data separately. Usually it's recommended to do the tokenization and text processing after you split the data. So that means you can prevent the data leakage. So it's recommended, it's strictly recommended actually to do the split and then tokenize. Some people may tokenize first and then split the data, but that's at least that's in my what I read, in my experience, I haven't seen people recommending to do tokenizing and then to go to the splitting the data. I personally recommend using Quanteda, split the data. I mean, split the data using whatever package. Let's say using the resample or sample, or maybe using caret package. And then once you split the data, you go to tokenizing. Once you tokenize, then you can train your model. So you have to tokenize, train, and test data separately, and then you can do the training, the algorithms. Having said this, I think the next thing will be getting our hands dirty and going into the details of how we can code that in R. So the first thing we need to do is we need to load the necessary libraries that we need, and these are prepared for data manipulation, and we may use also ggplot2 in case we are doing some kind of visualization, and we can use a caret package to do the splitting our sample into train and test data set. At the end we will need bib2df as we did last time to read our bibtext data, bibtext data. So we will need to use this package. Let me read them. And then once I load this library, the first thing that I need to do is I need to show you, I need to load the package, I mean the data frames, the bibtext data. So the bibtext, the data that I am going to use are here. So I'm on line R, so I have it here. COVID. Here we are. So as I said, I was searching the literature in PubMed. One is about COVID and the other one is about SARS. So we will read these references. It's like there are 600 each, I believe. And then that means we will have about 1,200 records for our data set. So the first thing I need to do is I probably need to set my working directory. So let me just go back, and I have path copy. So it's simple. I can simply go here and then copy my Unix path. Then I can simply set my working directory, and then once I set my working directory, I can have access to my files. So first thing that I need to do is I need to read this COVID-19 data frame. So the COVID-19, I believe it's written as COVID-19. So this is the COVID-19 data frame. That's a bibtext file, so that's why it has the bib-int. Then once I read that, I can have access to, I can convert this bibtext file into a data frame. The next one is SARS. So let me call that SARS, and then I can simply read this. SARS bib2df, as I said, it's the name of that data frame, I mean that bibtext file is SARS. So I read this. Then once I have read that, I have 600 observations and 32 variables for COVID. And for the next one, I believe there's some kind of ignorable error, because some of the in some of the records in my bibtext file, there are some problems, some issues, how the bibtext file is written. When I export, first I was exporting these references from PubMed to Mendeley readable format, and then from Mendeley I was writing it into bibtext file. That's a very minor procedure which you can do it in Mendeley reference management information system software, and then you can easily convert it to bibtext. Once you convert it to bibtext, then you can read it in R. There are also other ways of converting bibtext file or maybe not readable or RIS or file to bibtext file. There is a package, but I have tried it and it didn't work, so it wasn't really successful. And that package is actually RevTools. It's called RevTools, I think. So you can look it up. I tried it myself and I wasn't successful. So instead, what I did is like I export the references from PubMed, and then read them in Mendeley, and then from Mendeley I was converting the file into bibtext file, from which I will be able to read them in my R. So as you see, we have about 826 records for SARS and 600 observations for COVID. Having said this, I think we go to the next session. So I will stop the video from here and continue from here for next time. Thank you, and I appreciate if you subscribe to the channel and like it, and share it to people who may be working on text analysis. Thank you.